Hi everyone, welcome to Electronics with Professor Mughal. Thank you again for tuning in. It's been a long time. I have been super busy, haven't had the chance to publish video as regularly as I've been doing in the past, but good thing is I'm back. In past few weeks or so, I have received a lot of emails, and there's one thing common about those emails is a lot of you were asking me how to display 4 different numbers on 7-segment display at the same time on an FPGA board. And not just that, in fact, some of you were really wanting to learn how to scroll a letter or a number onto, say, going from right to left or left to right onto the Basys 3 board using the 7-segment display. So in this very video, I'm going to show you a very simple way using case statements how you can display 4 different numbers or 4 different letters onto 7-segment display and then also scroll them. But before I get started, I just want to remind you to subscribe to the channel if you haven't already. And I also would like to thank Yusuf, Digo, Gabriel for their support signing up onto Patreons. And I highly encourage all of you to become a part of my community where you can have access to project files. I want to take you to the demo for today's project. I want to explain you how the end project may look like, and then from there we will just go straight to the coding part. So if you are belongs to a generation Z of millennials, that means you were born in 2000 or after that, you're basically a millennial who belongs from generation Z. And what we are doing here on this Basys 3 board, we are going to display your date of birth. So it's going to be extremely important for someone who is a millennial and from generation Z. So right now, if you look at the 4 switches right here, the first 4 switches, you can use those 4 switches to set a birth date. So right now, by default, if I press the center button, which is a reset button, it's going, because the 4 switches are set to 0, it's just going to display 2000, and then it's basically scrolling. It's wobbling a little, but it's basically displaying 2000. So you see it's 2 right here. It stays for 2 seconds and then it starts scrolling back again. If I set the switches all the way to 1, 4, that makes all the 4 switches are high. It makes a code for 2015, and now you see it's actually displaying 2015. Stays there for a couple of seconds and then starts scrolling back again from right to the left. So the user can come in and put a date of birth using these switches. So 0011, that would make 2003 if you were born in 2003. So that is what it's going to display, and then scroll. Now I wanted to keep it simple, so I went with 4 switches. You can increase the number of switches, you can increase the length of the message or character or number, but if hopefully by the end of this video you know how you can do that. So I'm just going to keep it simple and go with the 4-bit configuration. And then remember, this is a center button, which is for the reset, and it just resets everything. So without wasting much time, let's get started. And again, for the sake of time, what I did, I already did the coding. Most of the coding is, not most, but a lot of coding is from the previous projects, like for example this binary to BCD and BCD to 7-segment. I'll leave the link in the description, and since I've covered these videos, covered these modules in a lot of my videos in the past, so I'm just not gonna talk much about it, but I want to talk about this main module, which is also my top module. This module is responsible for scrolling the number and also displaying 4 different numbers onto the screen. And like I said, I'm gonna keep it simple, and I'll try to explain each line in the code, and I'll try to go as slow as I can, but remember there's some prior knowledge that is needed, and I highly encourage you to look at some of the videos in my playlist and try to understand and get the basic understanding of how Verilog works. So this part here is the topology. I got the clock, which is the system clock. Remember, I have a Basys 3 board. So the board has a frequency of 100 megahertz. There's a reset button that I mentioned. It is the center button. I also have the 8 switches, and the reason I have 8 switches is because, like I mentioned earlier, I'm using this module right here, binary to BCD, from my previous project. However, in this project, I'm only going to use the first 4 switches, okay, even though, you know, I got 8-bit. But I'm only using the first 4 switches to enter the date of birth. So technically it can display a date of birth from 2000 to 2015. You can increase the number of bits, and hopefully, you know, by the end of this video you should be able to do it easily. It's just an easy fix. And then finally I got the 7 segments, and then this over here is for the enabling these 4 7-segment display. And again, I want to quickly mention I have the Basys 3 board, so it's got 4 7-segment displays. These are active low, and we are going to keep one on, the other 3 off, and then similarly it just keeps on doing it. This is enable, then this is enable, then this is enable, and then this is enable. It just keeps on happening at a refresh rate, at a frequency that human eye cannot detect. We feel that all these 7 segments are on at the same time. However, for a very fraction of a second, this is on, the other 3 off, and then this is on, the other 3 are off, and so on. It's just keep on doing it in the loop. Okay, now these numbers that you see on the board, they are scrolling every 1 second. The very first thing I need to do is to set a timer. Okay, for every 1 second it scrolls to the left, and therefore I'm using this line number 15 ticker. It is going to be a register because it's going to keep you know, holding, it's going to hold on to the what is the count value is. Since the board has a frequency of 100 megahertz, so we're looking at 100 million cycles, and one clock cycle has half is for the half time it's 0, the other half it's 1. So we're looking at basically 50 million clock cycle, and therefore the bit size is 26 bits. 0 to 25 makes 26 bit, because that would allow us to count up to 50 million. I have a wire click over here, and initially I'm going to use this to assign a value of 0 and 1 that would indicate 1 second has elapsed, and that is when the counter, the number on the display will shift to the left on the 7-segment display. I also have the 4-bit registers, and I have named them as first, second, third, and fourth. Remember, this is the rightmost 7-segment display on the board. This is the second, and similarly this is the leftmost segment on the Basys 3 board. They can display on a single display. You can have a number anywhere between 0 to 9, and therefore I have a 4-bit. Now this part of the code, what it's doing is basically generating a clock, 1 second clock. The number shifts to the left, scrolls to the left every 1 second. So whenever the positive edge of the clock arrives or a reset button is pressed, if the reset button is pressed, ticker goes to 0. That means it's basically a count, okay, that I have just renamed as ticker. If the ticker count has reached 50 million, that means 1 second has elapsed. That means it needs to reset this count and goes to 0. If not, then the ticker should go up by 1. And this line over here, line number 30, it basically says ticker when it reaches a value of 50 million. If this condition is true, then set the value of the click to 1, else it's going to be 0. So for the half, 50 million cycles is 0, and the other 50 million cycles it's going to be on, and that makes a 1 second clock, and therefore it rotates every 1 second. Now let's move on to this part of the code right over here. We are going to create a register which I have named as click count. It's a 4-bit register. We should be able to, if you want to, you can change the size of this register. However, I'm just going to keep it to 4 bits, and I'm going to show you how I am using this you know, to my advantage. How I'm using this to scroll numbers on the 7-segment display. In order for me to get into more details about how I am using this click count, for this part, what I'm trying to do is every time the positive edge of the clock arrives or the click arrives, which is this ticker every 1 second I want the counter to go up by 1. So if it's a reset, then click count goes to 0. And then if it's actually 8, then I also would want it to go to 0. Else it's just keep on incrementing by 1. So you basically will have 8 cases. Okay, 0 to 8, 9 cases. And I'll show you what I will do with those 9 cases. Remember, the trick is to use these case statements to scroll the numbers. Okay, all right. Over here, 48, 49, this is the binary to BCD. Again, you know, this is something we have done in the past many times. I just instantiated that module over here. And remember, this is the input. This is the ones, tens, and hundreds. And these are basically these right here. Okay, so that's what the first, this is the number that will be represented on the rightmost 7 segment, for example, right? Okay, now comes this click count. What's going over here? Remember, we have 8 cases, so 0 to 8, basically 9 cases. Okay, now when the first case, let's look at the first case, which is 0. If the click count initially, it's going to be 0 at the beginning when board is turned on. Remember, I want to take you back over here actually. Okay, when I press the reset or when I turn the board on, this is displaying 2 on the rightmost 7 segment, right? So I want to display 2, so my first is equals to 2, and my second, third, and fourth, these are the 3 7 segment display on the left. Those are going to be just simply 0. Okay, so if I just reset and say they're 0, now they are moving to the left. And because, so I'm just gonna push all these switches to 0. You got 2 triple 0. Remember, this represents the hundreds, tens, and ones. So we're gonna keep on scrolling that to the left. So if I go over here now, so it's basically representing 2 triple 0, right? Okay, all right. What should happen when the next cycle arrives? That means the click count goes to 1. Well, 2 should move, scroll to the left. This 0 should go over here, and this 0 should go over here. And there should be a new number that should arrive over here, and that would be hundreds. And that's what it is over here. That's what it is over here. And then similarly, when the next counter comes in, so the count will go from 1 to 2, hundreds will move over here, 2 will move over here, and 0 will move over here, and at the first we will have a new number that comes in, which will be represented by tens. And similarly, we have ones over here. So it's keep on scrolling. Once we get over here, when the fourth cycle comes in, that is when it's basically displaying the date of birth, like 2000 or 2015 or 2011, something like that. I wanted to hold that for 2 cycles. So therefore, if you look at case 5 and case 6, they are pretty much same. I got the leftmost segment is going to display 2, and hundreds, tens, and ones, those are going to display the 4-bit number that we have. Okay, anywhere from 0 to 15. And after that, they will just start scrolling back again to the left. So this was hundreds. Hundreds will move over here. 2 will move over here. Ones will move over here to the tens, and tens will move to the place of hundreds. And that's what we have over here. And it keeps on doing it. So when I was saying you can change this number, like I have 9 cases. If you like, you can have 10 cases or 11 cases, whichever way you want to scroll it. I thought for me 9 is more than enough, so I just stopped here. I hope you got that point. That was the tricky point, and it was not that tricky, but this was a simple trick on how to do it. This part of the code is going to be responsible for turning the 7 segments on and off. Like I told you, we have to refresh the 7 segment one by one, so one stays on, the other 3 stays off. This part of the code, this is what it's doing. So I have a local parameter and I'm assigning it to a value of 18. Now this does not really need to be 18. It could be anything above 2. Anything 2 or above. Okay, you basically need 2 bits over here because you have 4 segments, right? 0, 1, 2, 3, so you need only 2 bits. And the reason I'm going with 18 is because this part of the code is copied from one of my source files, so I just didn't want to change that. But it's the same thing. I declared that as a register, simple count, and this size, again, like I said, it could be changed, but we basically need a 2-bit counter to control 4 segments. So I have, will need 2 bits. And then I have a always add block. This count will increase every time the positive edge of the clock arrives. If a reset button is pressed, then it's basically 0. And then else count will actually go up by 1. I also have 2 registers over here. One is the Y and the other one is the enable underscore temporary. They both are 4-bit and they are going to store a number. So Y is going to store a number that it takes from this switch, okay, as an input. And then enable underscore temporary, it's for enabling the 4 7-segment display that we have. So we have a 4-bit size for each of those variables. Next up is we are going to use an always add black. This asterisk sign basically represents that your output is dependent upon all the input ports mentioned above. And when I say output, I basically mean Y, which is the number that is going to be displayed on the board, and also to turn on one of the 7 segments. So I got those 2 variables declared as output. And what are those input ports? Those are clock, switches, and the reset. Next up is we're going to start off by saying begin and then say case count n-1 colon n-2. Remember, n is 18, which I mentioned above. So 18 minus 1 gives you 17. And then n-2 would be 16. So 17 colon 16, that basically are 2 bits. And those 2 bits can have value 0, 0, 0, 1, 1, 0, and 1, 1. This is something we have done previously as well. When the rightmost 7 segment is enabled, so I want to show you over here. When this segment is enabled, we want to display 2 over here, right? And similarly, we're gonna have this one on, then this one on, then this one on, and this one on, and this all being active low, we need to set the logic to 0. So for 0, 0, the rightmost segment is going to be on, right? And it should display first, which is the rightmost 7 segment should display first. Similarly, if the counter goes up by 1, it's 0, 1. The second LED should be on, the other 3 should be off, 1 represents off, and then Y should display second, and so on. And lastly, when we have 2B11, that means the last 7 segment display should be on from the left, the first one from the left, and the other 3 should be off, and it should display fourth. Remember not to forget this first, second, third, and fourth right here. These values are coming from the module that we had instantiated on line number 49. Okay, so the input right here in ones, tens, and hundreds, which initially we also declared as a register as fourth, third, second, and first, where again first will basically display the number on the first 7 segment display from the right, and the fourth number will be displayed on the 4th segment, which is the leftmost 7 segment. Finally, we are going to assign the enable equals to en underscore temp. So whatever that value is will get assigned in the output variable. Remember, you are assigning value to 2 variables at one time, so it's important to have begin and end for each of those. And similarly over here, when you were doing the case statements for the click count, you have begin and end because you are assigning value to more than 1 variables. Lastly, you have the BCD7 segment, which is going to display whatever the number that you have over here onto the 7 segment display, which is this module right here. It's pretty simple. If the number is 0, then it's going to make sure that 7 segment displays 0. If the number is 1, then it makes sure that 7 segment displays 1. And you really don't need to go beyond 9 because we really don't go beyond that. But I just kept it in there because I was using a source file from the past, and really it's not going to have an impact upon the functionality. So just to summarize one more time, here is your topology right here. This part of the code is basically making sure that you have a 1 second clock because the number scrolls to the left every 1 second. This part of the code is just making sure you have a click count register. It is a 3-bit register, actually a 4-bit register, right? And we're going to use this click count register to create 9 different case statements, okay? And those 9 statements were over here, where we just, for each statement, initially we want to display 2000. This 2 then shifts to the left every time, and therefore it appears over here. And then the new hundreds wire comment, which will carry a 4-bit number right here. I'll just keep on doing. We also wanted to make sure that we hold on to these values for a couple of seconds. So therefore we have 4, 5, and 6. They're basically actually 5, 3, 4, and 5. We basically have the same stuff right here. So that was pretty much it. If you look at the constant file, I have the clock up first, and then I have the reset, the center button, then I have 7 segment, 4 enablers, and then 7 switches. The reason I got 7 switches, 8 switches actually, is because I have 8 switches over here. Remember, we are only using the first 4 switches. It looks like my implementation is complete. I'm going to generate the bitstream file, so let me click over here. Okay, alright, the bitstream is complete. Click on program device, make sure your board is connected to your PC. It should automatically pull up the bit file. I'm going to click program, and I'm going to show you the implementation of the project onto your Basys 3 board. So look at over here again. It's basically going to display 2000 initially, and the reason for that is because all the switches are set to 0, 0. This switch, and this switch, the 4 switches. Okay, if I turn those on, and that makes a code of 15, so it's going to display 2015, and it just keep on scrolling to the left. Once it displays 2015 like it does now, it stays for a couple of seconds and then moves on, keep on scrolling back and forth. So I hope that you enjoyed this video. I wanted to keep it very simple, so I have a 4-bit length character, or in this case it was a number, date of birth. But if you want to, you can change the length of the number. So I hope you enjoyed this video again, and if you haven't already, please subscribe to the channel. Till next time, take care, stay safe, enjoy your rest of the day.